Good morning, dear students. The second session of the wave optics. We are going to start with it. Last class that we have studied about how the light is behaving like two different nature, particle nature, everything that we have already discussed. For reflection, refraction, these are all the things that we have discussed about how it is behaving like a ray. And when it comes to wave, how we are saying that it is a wave, that is we are going to discuss it. Okay, so you can see here, as a continuity of the last class, there is a two different rooms. Okay, and the rooms are separated by a wall. A hole is made in a wall, and we are going to find it out how the light is penetrating through wall and how the light is spreading throughout the room. That is what we are going to see it here. According to Huygens theory, the light can be of wave nature, and he got this idea from a simple observation. What are all the things that he observed? That is what we are going to see it here. In an experiment conducted by the Newtons and Huygens, the room was constructed with an obstruction in the middle. Obstruction means it is the wall, and Newton considered a boundary and Huygens considered a door as the obstacle between the room. A door as an obstacle. In between there is a door. And in this experiment, the light was switched on in the one room. In this room, the light is switched on. Okay, when the switch is on in one room, the light enters in the second room through the door. Okay, so according to Newton's, light travels straight line. Then the first room will be bright, and second room is also got some amount of light. For example, imagine that the sun is rising in the east, and in your room you have a window. The light is coming through the window. If you see from the window, you can see the sun because the light travels in a straight line. And you have one more window on the west side of the room. If you go and see over the window, there also the light is coming inside, but you can't see the sun. If the light is traveling through straight line, from west side also, if you see the brightness, see the light, you should see the sun, no? But it is not happening. Why it is not happening? Because the light have one more different property. It is diffracting, that is bending of the light which is happening. So we can consider that it is a wave in nature. Okay, so Huygens observed that the first room become bright and the light spread in the second room as well. Okay, so therefore Huygens proposed that the light might be of wave nature also. So as wavelength of light is small, therefore the wave nature of light cannot be seen. If the light is made to pass through the small portion which comparable to the wavelength of the light, then the wave nature of light can be observed. Okay, according to Huygens says that the light is having wave property. Newton says that the light is having particle nature. So according to Huygens, Newton's theory was not fully correct. Therefore, he gave an idea that the light is of wave nature. For example, you can see here, if a light is made to pass through a big window, the light will appear as ray, not as a wave. But if the light is passed through a very small hole, the light will behave as a wave. That is what their observation. Okay, and Huygens' idea was not accepted because of the following reason. Initially, Huygens says that the light is having wave nature, but nobody was ready to accept that it is a wave nature because according to Newton's theory, it is a particle in nature. Everyone already know that, but they are not ready to accept that the Huygens principle that it is a wave in nature. Okay. 1 minute. Okay, the cursor should be visible, no? That is why I made a small adjustment. And there was a Newton's authority. when it comes to here, as there was no experimental proof. He tried so many times and he tried to say that it is a wave, but he couldn't prove it in a solid way in an experimental method. In experimental proof, he cannot create that. So that is why Huygens, whatever he proposes, that the people are ready to accept it blindly. Because if we want to accept something, means there should be some proof, but he can't create the proof initially, so that he finding it difficult, and people are not ready to accept that the light is in wave nature. And at that time, Newton is the authority, so people are following only Newton, not the Huygens. Okay, so wave always needs a medium for propagation. You know that sound is a wave, right? But we have already studied that sound needs a medium to propagation. In vacuum, sound will not travel. Why? Because it is a wave. Okay, so this means if you consider that light is also a wave, how it is penetrating through the vacuum? Because the light is coming from the sun and it is entering into the earth. Between sun to earth there is no medium, it is a vacuum. Then how the light is coming through the medium? So we can't believe that the light is a wave. That is what people blindly are not ready to accept the Huygens idea. Okay, this means the light cannot propagate through vacuum, but sunlight able to reach the earth surface. So as a conclusion given by Huygens, formed on the basis of wave nature of light. Okay, so many other scientists came after Huygens, tried to prove that the light is a wave in nature. Okay, and who are all the scientists? They tried to prove that the light is wave in nature. Thomas Young in the year 1800 and Maxwell in the year 1860. They also tried to prove that the light is having some set of wave nature, and they can't do this. Okay, as you can see here, Thomas Young is the scientist who tried to prove that the light is wave in nature in the year 1800, and James Maxwell, he is the scientist who tried to prove that the light is a wave nature in 1860 by various kind of experiments and practice techniques. And Albert Einstein's photoelectric effect in the year 1900. So Albert Einstein also tried to prove that it is a wave in nature. And light, a particle or a wave, till while the discussion is going on, as a conclusion they say that light has dual nature of light. They discuss about the dual nature of light. So they come to the conclusion that light is having particle nature as well as it has wave nature also. Light has both wave as well as particle nature. Light can behave either as a particle and or as a wave depending on the situations. According to the situation, how it acts. Dual nature is also shown by electrons, because Albert Einstein says that the photoelectric effect, it behaves like a wave as well as particle. So that is why they come to the conclusion that light is an electromagnetic wave. So this is considered as a wave, and the light is going from one point to another point as a particle also. So when particle nature of light is considered, then the photoelectric effect and the Crompton effect, these are all the thing it is considered. And when the light is considered as the wave, the properties such as interference and diffraction, polarization also explained. You can see the flow chart here. If you consider the light as a particle, reflection, refraction and photoelectric effect, these are all the things can be explained if you consider the light if it is a particle. And if the light, if it is a wave, interference and diffraction, polarization, these are also having the properties that it can be explained. Okay, diffraction, polarization and interference, these are all the three properties can be explained if you consider the light is a wave in nature. Okay, rest of the thing that we will discuss in the next class. Go through the video repeatedly till you get understand. Okay, thank you.